Dear students, welcome to GRM Toppers Classes, Hyderabad, the premier institute for G Mains, G Advance, along with the foundation classes for mains and advance, is the one well recognized institute in Hyderabad producing so many remarkable ranks in the history of G Mains and Advance. For more details, please contact 94921 92486, provided in every page in the bottom. Welcome to every aspirant for G Mains and Advance. And dear students, in today's discussion, let us go for paper discussion of G Advance 2020. And in part 1, let us go for discussion of paper 1. Now, dear students, once again, welcome to the session today, and go to the discussion now. Okay, friends. Now you see, you have 3 sections of this paper 1. And in section 1, you will be given 6 questions. Each question has 4 options, in which only one of these options is the correct answer. And that correct option must be answered now. Now, dear friends, let us go to question number 1 here. So, this is the first question of this paper, which is given as, suppose A comma B denote distinct real roots of quadratic polynomial, this one, and suppose C comma D denote distinct complex roots of the quadratic polynomial, this one, then AC of A minus C plus AD of A minus B plus BC of B minus C plus BD of B minus D equal to dash. And the given options are like this: A0, B 8000, C 8080, and D 16,000. Okay, friends. So this is one simple question, I feel, because there is no much difficulty in solving this question. Data is very clear. Even concept is also very simple. But only thing is just to evaluate this one with the values from the given data. See, here A and B denote the distinct roots of this equation, so that sum of the roots can be taken as A plus B equal to minus 20. Product of the roots AB is minus 20, 20. And because C comma D are the roots of this equation, sum of the roots c plus d is 20. As you know the formula for sum of the roots and product of the roots, CD is 20. Okay. Now you can find a square plus b square as well as c square plus d square before going to the question. Here a square plus b square as a plus b whole square minus 2ab, where a plus b is minus 20 square is 400, ab is minus 20, so that minus 2ab is 40, so that sum is 4440. And c square plus d square can be taken as c plus d whole square minus 2cd, and substituting the values, the value of c square plus d square is minus 3640. Now dear friends, this AC of A minus C plus AD of A minus D, BC of B minus C plus BD of B minus D can be taken as, here AC and A is A square C, here AD and A is A square D, so that this is A square of C plus D. Similarly, here B square of C and B square of D together, B square of B plus D, C plus D, so that you can separate the terms like this A square plus B square of C plus D. And similarly, AC of minus C is minus C square of A, BC of minus C is minus C square of B, hence minus C square of A plus B you will have. Similarly, minus D square of A plus B together can be written like this. And all these values have been already found in advance. Now just substituting, so these values and simplifying, the answer is 16,000. Therefore, the right answer is D here, my friends. So that this is very simple, just finding A square plus B square, C square plus D square, and you can transform this question according to the known values, and just substituting you will get the value of the question. Hence, dear friends, you can even accept that question is very simple. Okay, now let us go to the next question. This one. Yeah, this is, I feel, somewhat good question, because I have darkened the question here. I have shaded the question. So you can consider this question is one good question. Okay, friends, now the question is, if the function f R to R means from domain R to codomain R is defined by f of x equal to mod x of x minus sin x, then which of the following statements is true is the question here. So given options are, f is 1 1 but not onto. Option B is f is onto but not 1 1. C is f is both 1 1 and onto, whereas option D, f is neither 1 1 nor onto. Therefore, it is very clear that asked to examine the function to be 1 1 onto. We have to verify whether the function is 1 1 or onto. But you know how a function will be 1 1 and how a function will be onto, based on the graphs and based on the analysis of the question, analysis of the function, you can examine. And here, because f of x is given as mod x of x minus sin x, You can separate the function for x positive and negative. Therefore, for x positive or 0, you can say it is x of x minus sin x. For x negative, because mod x is minus x, can be taken like this. Now just multiplying these two, it is x square minus x sin x for x greater than or equal to 0, whereas minus x square plus x sin x for x less than 0. None. Got the point? Now I want to differentiate here itself, then f dash x will be taken as, because I want to verify whether it is strictly increasing or decreasing or not. For that I am going for f dash x. F dash x is now 2x minus, here differentiating x sin x by uv rule. So sin x minus x cos x for x greater than 0. Because when you are going for differentiation at 0 cannot be considered unless we go for left derivative and right derivative. Okay. So I am not considering equality here, but differentiating this one, 2x minus sin x minus x cos x for x greater than 0, and minus 2x plus sin x plus x cos x for x less than 0. Now substituting 0 in both getting same, you can say it is f dash 0, otherwise not. Now substituting 0, this is 0, this is 0, this is 0, you are getting 0 for right side of 0, and also 0, 0, 0, that means f dash 0 minus is also 0, so that f dash 0 is 0, you can accept. Now here this 2x minus sin x minus x cos x for x greater than 0 can be written like this, separating 2x, one for sin x and one for cos x. This is x minus sin x plus x of 1 minus cos x, and similarly separating minus 2x also, one for sin x and one for cos x. It is minus of x minus sin x minus x of 1 minus cos x. What for? Now you can see here, because for x greater than 0, x is more than sin x, so that x minus sin x is positive, and for x greater than 0, cos x is less than 1, so 1 minus cos x is positive. You can see the graph of cos x, just on the right side of 0, cos x will be somewhat smaller than 1, so that 1 minus cos x is positive as well as x is positive. On the whole, f dash x is positive for x greater than 0. And for x less than 0, dear friends, x less than 0, x minus sin x will be negative, because x will be below sin x. X will be below sin x. So that on the left side of 0, on the left side of 0, therefore this x minus sin x will be negative, so that minus of this become positive, minus of this become positive. And also this minus x is positive for x less than 0, and 1 minus cos x, 1 minus cos x for x less than 0 also positive. Hence this total is positive now, because anyway this is positive, even though sometimes this is 0, on the whole this will be positive. Therefore, dear friends, f dash x will be greater than 0 for every x belongs to R deleted 0. F dash x is greater than 0. And what is f dash 0? F dash 0 is 0. F dash 0 is 0. Otherwise, f dash x is positive. Therefore, on the whole, you can say f of x will be increasing. Though f dash 0 is 0, at that point just tangent become horizontal, but on the left and right it is increasing, so f of x will be increasing. So when f of x is strictly increasing, what you will say? F is 1, 1. Why? Because every horizontal line will meet the curve at only one point. Do you know how do we verify a function given by a curve, whether it is 1, 1 or not? Will be verified by a horizontal line. If any horizontal line in the codomain, if any horizontal line in the codomain meet the curve at more than one point, it will not be 1, 1. But when f is strictly increasing, the horizontal line, every horizontal line will meet the curve at only one point, my dear friends. Hence, f is 1, 1. Right. Now, let us try to verify whether f is onto or not. And from this one, what is f of minus x? So, because f of x is this one, f of x is this, f of minus x can be taken as anyway mod x is x, this is minus x, sine of minus x will be plus sine x here. Sine of minus x minus sine x, and this minus become plus, taking minus common. So, f of minus x will be minus f of x. From this function you can straight away put x equal to minus x in place of x and see the result. It become minus f of x. Therefore, f of x is, because f of minus x is minus f of x, is an odd function, right? When f is an odd function, will be symmetrical about the origin, and moreover f is strictly increasing. When f is strictly increasing, it will be non-periodic. It will be non-periodic because f is strictly increasing, and also continuous. Why it is continuous, sir? You can see this x square minus x sin x for x greater than or equal to 0, minus x square plus x sin x is also continuous, because it will be defined for every real value of x. There is no value of x where f of x is undefined. Therefore, f of x is continuous. It is non-periodic, continuous, and strictly increasing function. Therefore, the range will be what? Range will be from minus infinity to plus infinity. Why? Let us see. As x tends to infinity, what about f of x? As x tends to infinity, f of x can be taken as, because x is positive, this positive function will be taken x square minus sin x. Now, taking x square common, it will be 1 minus sin x by x. As x tends to infinity, the sin x by x tends to 0, none. Why? Because sin x is finite, which lies in the interval minus 1 to 1, x is infinite. Therefore, 1 minus sin x by x, the sin x by x becomes 0, 1 minus 0 is 1, and as x tends to infinity, this is x square tends to infinity. Got the point here? And then limit x tends to minus infinity, f of x. As x tends to minus infinity, x is, that means function will be taken for x negative. So, for x negative, this is the function. What is that? Minus, what do you say? This is minus x square plus x sin x. Minus x square plus x sin x. Again, taking minus x square common, it is 1 minus sin x by x. The sin x by x tends to 0. So, this is 1. This is 1 into minus infinity. So, on the whole, this goes to minus infinity, because as x tends to minus infinity, x square tends to infinity, but minus is there, and this is 1 minus 0. So, minus infinity into 1 minus 0 means 1. So, minus infinity into 1 minus infinity. Therefore, as x tends to minus infinity, this goes to minus infinity. As x tends to plus infinity, f of x goes to plus infinity, and it is continuous, strictly increasing. Altogether, curve will be taken from minus infinity to plus infinity, which is the total real set. Hence, the range of the function will be the whole real set minus infinity to plus infinity, which is equal to the codomain of the function given. Hence, the range of f is this, which is equal to codomain. Hence, the function will be said to be onto. Therefore, f is both 1, 1 and onto is the right answer. Hence, from the given options, you can see that what are this? F is both 1, 1 and onto is the right answer. F is both 1, 1 and onto is the right answer, my dear friends. Now let us come to the next question, third one. Yeah. So please read the question thoroughly, then try to answer this question. Of course, this is also one good question. Let us see now. Okay, I will mark it as good question. Right? Okay, friends, this is also one good question. Yeah. What is the question given here? Let the function f arc to r and g arc to r be defined by f of x equal to e power x minus 1 minus e power minus of x minus 1 minus of mod of x minus 1. Just you look at this function and get your own idea. G of x is half of e power x minus 1 plus e power 1 minus x. Then the area of the region in the first quadrant bounded by y equal to f of x, y equal to g of x, and x equal to z. So dear friends, this is the question on the areas under curves. This question is on the concept of areas under curves, which is related to second year calculus. Now dear friends, given options are like this. Now let us write this f of x defining this mod of x minus 1. So this f of x can be taken as when x minus 1 is positive or 0. This mod of x minus 1 will be taken by x minus 1 only. Mod of x minus 1 will be taken by x minus 1. Right? When x minus 1 is less than 0. So this mod of x minus 1 will be taken by minus of x minus 1. Become minus of minus plus. Therefore, f of x is 0 for x less than or equal to 1. Why? Because when it is less than or equal to 1, it is minus of x minus 1. Minus of minus become plus. Right? So this is e power x minus 1. This is also e power x minus 1. E power x minus 1 minus e power x minus 1 becomes 0. Therefore, it is 0 for x less than or equal to 1. Whereas for x greater than 1, because it is the mod about x equal to 1. On the right side of 1, x minus 1 is positive, will be taken as x minus 1. For x less than 1, x minus 1 is negative, will be taken as minus of x minus 1. So like that, f of x will be 0 for x less than or equal to 1. And e power of x minus 1 minus e power of 1 minus x, because it is minus of x minus 1 become 1 minus x for x greater than 1. When this is f of x, let us find f dash x. So because it is 0, constant f dash x will be 0, and differentiating this one, e power x minus 1 is e power x minus 1, and e power 1 minus x is derivative become e power 1 minus x of minus 1 become this for x greater than 1. Because I want to take the graph of this f of x and g of x. That's why I am studying the nature of this curve. So f dash x is like this. But here e power x minus 1 and e power 1 minus x, it is positive, no? E power x minus 1 and e power 1 minus x. E power either positive or negative, it is positive. E power either positive or negative, the value is positive because you know the curve of e power x will be above the x-axis. So this is positive value. Therefore, f dash x is either 0, of course it is 0 means x-axis, and from there onwards, from 1 onwards, it will be f dash x is greater than 0 means f of x will be increasing. So now you can say this. Then what is f dash 1 plus? So f dash 1 plus can be taken as this one, 2, just on the right side. Anyway, so from there onwards, it will be increasing. F of x will be increasing. Of course, I have found f dash 1 plus even using this one. This will be 2, substituting just 1 here because f dash 1 minus is 0. 1 minus is 0, but 1 plus is 2. So to say that f is not differentiable at x equal to 1, I have taken f dash 1 plus. Of course, not necessary here, but here. Let us go for g of x. G of x is given as this one. G of x is given as e power x minus 1 plus e power 1 minus x. So e power 1 minus x on the denominator, it is 1 by e power x minus 1. But e power x minus 1 is positive value. So this is like x plus 1 by x form, where x is positive. E power x minus 1 is one positive value. 1 by e power x minus 1 is the reciprocal of that. But sum of the reciprocals of one positive value will be always greater than or equal to 2. When this is greater than or equal to 2 into 1 by 2 greater than or equal to 1 according to EAM greater than or equal to GM. So it is half of 2 because it is greater than or equal to 2 will be greater than or equal to 1. So g of x will be always greater than or equal to 1. And what is g of 1? G of 1 will be 1 here. Substituting 1 here, e power 0, 1, e power 0, 1. So that g of 1 is 1. And what is g of 0? At x equal to 0, it is half of e plus 1 by e. Anyway, this is more than 2 into 2. It is more than 1. G of 0 is more than 1, but g of 1 is 1. Therefore, g of x is minimum at x equal to 1. Why? Because just now we said g of x is greater than or equal to 1. No? That 1 is happening at x equal to 1. Therefore, g of x is minimum at x equal to 1. G of 0 is more than 1, even on the right side of 1. So that g of x will be more than 1. Right? Just we are studying the nature of g of x. Now, even studying g dash x also. G dash x is when g dash x equating to 0, you are getting x equal to 1 because this is g dash x. At x equal to 1, you will get 0, 1 minus 1. And g double dash x is this one, greater than 0. Therefore, in another way, you can say that g of x is minimum at x equal to 1. In another way, you can say g of x is minimum at x equal to 1. Okay. Therefore, g of x is minimum at x equal to 1 and g dash x will be increasing. Means the slope of tangent on g of x will be increasing. Of course, g double dash x is greater than 0. Anyway, so from this point of observation, right, one thing we got g of x is minimum at x equal to 1, g of 0 is more than 1, and g of x is increasing from 1 onwards. In between 0 and 1, it will be decreasing because at 0 it is more than 1. At 0 it is more than 1. G of 1 is 1 means from more than 1 to 1 it will be decreasing. Right. Now you have some idea. Therefore, g of x is minimum at x equal to 1 and you can say other points of g of x. And f of x equal to g of x, what happens? We are verifying whether they are intersecting or not. That is also one point to be known. For that, I am equating f of x and g of x. So when these are equal, right? So I have e power x minus 1 minus e power 1 minus x equal to this one. So that e power x minus 1 equal to 3 of e power 1 minus x, right? Now taking log on both sides, x minus 1 equal to log 3 plus 1 minus x, log 3 plus 1 minus x. Okay. Now, of course, this also can be taken on one side and directly you can write. So e power 1 minus x can be taken as e power 2x minus 2. Then 2x minus 2 can be taken, and you can write log 3. From that also you can do, but I am doing like this. X minus 1 equal to log 3 plus 1 minus x. Then taking x on left side, it is 2x equal to 2 plus log 3. Then x equal to 1 by 2 of 2 plus log 3. So 1 by 2 of 2 is 1, and 1 by 2 of log 3 is log root 3. 1 plus log root 3, right? Now, from this exercise, even I am finding this f of x minus g of x, f of x minus g of x will be what? Either positive or negative or changing sign. For that, f of x minus g of x can be taken like this. F of x minus g of x is e power x minus 1 minus e power 1 minus x and half of this, right? Which is half of e power x minus 1, this one. And what is h dash x? H dash x is this, which is always positive. When this is always positive, h of x will be always increasing. That means f of x minus g of x is always increasing. F of x minus g of x is always increasing, right? Therefore, from all this, you can have the curve like this. Of course, some interesting features want to know about f of x and g of x. So because this is 1 plus log root 3, just more than 1, just more than 1. So these two curves will be intersecting on the right side of 1, on the right side of 1, right? See, coming to f of x, up to 1. Of course, even for x less than 0 also it is 0. X less than 0 also it is 0. But up to 1 it is 0. Up to 1 it is 0. 1 onwards it is increasing. Of course, f of x is not differentiable at x equal to 1. Right? From 1 onwards, f of x is increasing. And this is the curve g of x now. This is the curve g of x, where g of x is minimum at x equal to 1. G of 0 is just more than 1. And on the right side also it is increasing. Now these two are intersecting at this point. Even that is not sufficient to know the position of f of x with respect to g of x, or position of g of x with respect to f of x. For that, I have taken f of x minus g of x, or g of x minus f of x, you can study. Now here, this is g of x minus f of x. G of x minus f of x is reducing. First it is positive, become 0, then it will be negative, means that it is decreasing. Which one? G of x minus f of x is decreasing. So that f of x minus g of x will be increasing. That's what we have seen. F of x minus g of x, this one, is increasing because this is f of x, this is g of x. Initially, f of x minus g of x is negative because f of x is below g of x. Because f of x is below g of x, it is negative. So that negative value is slowly coming to 0, means increasing. From 0 onwards, f of x minus g of x is increasing. Therefore, from all the study of f of x and g of x, from all the study of f of x and g of x, what happens? So that graph of g of x will be like this, graph of f of x will be like this, and this is the point of intersection at 1 plus log root 3, right? Now, this is the area between f of x, g of x, and x equal to 0, and x equal to 0. Now, finding the area of this shaded region is also one interesting point. Finding area between this curves and the area of this shaded region is also an interesting point. For that you see, up to this it is 1, 0 to 1 this is 1, but g of x is only one function, because f of x has two parts. For less than 1 it is 1, for more than 1 it is 1. Therefore I have taken even shaded region also two parts, 0 to 1. Under g of x minus 0, of course this is 0, g of x minus 0 can be taken, that is g of x, plus 1 to this 1 to 1 plus log root 3. 1 to 1 plus log root 3, g of x minus f of x is, already we got f of x minus g of x. No? Now that is this function I have found. See, this is where is that? F of x minus g of x is this. So negative of this one is g of x minus f of x. That's why it is 3 e power 1 minus x, e power x minus 1. And you know how to integrate e power x. E power x is like integral e power x, right? So this is the integration part. That is, I think you are comfortable with the integration. Just substituting the values, going for integration and substituting the values, you will find it as e square minus 1 by 2e plus 2 minus root 3. I think there will be no problem in the simplification. Dear friends, you can understand this simple integration and you can substitute the values, simplify. But the thing is, so getting this area of that means region of required area is most important, and analyzing the curves is most important. So that part we have explained here in a well defined manner, in a very good manner. I hope you understand this one. Otherwise you can review this video and see the discussion once again. Okay, therefore dear friends, out of the given options, now this is e square minus 1 by 2e plus 2 minus root 3. No, see which one is correct one, right? See, so this is 2 minus root 3 as it is. So e minus of e power minus 1 become e square minus 1 by 2e. E square minus 1 by 2e plus 2 minus root 3. So 2 minus root 3 has only these two options, and this is e square plus 1 by 2e, whereas this is e square minus 1 by 2e. Hence can be taken, this is the right option. 2 minus root 3 is common. This is e square. If you want, you can write 1 by 2 of e minus 1 by e, or e minus e power minus 1, you can write. Okay friends, this is one very good question, and one has to discuss this kind of questions for good aspirants. Okay, right? Now let us go for next question. Here this fourth question. See, here you are given by, let a comma b and c be positive real numbers. Suppose p is an end point of the lattice rectum of the parabola y square equal to 4cx. Of course, some parameters have been changed. Something y square equal to 4 lambda x has been taken as y square equal to 4cx, right? Hence, you need not worry about the data. So the parabola y square equal to 4cx, and suppose the ellipse x square by a square y square plus y square by b square equal to 1 passes through the point P. If the tangent to the parabola and the ellipse at the point P are perpendicular to each other, then the eccentricity of the ellipse is the question. Dear friends, before answering this question, you must get the data in mind properly and begin the solution. So here let a, b, c be positive numbers. Suppose p be an end point of the lattice rectum of the parabola, and suppose this x square by a square plus y square by b square equal to 1 passes through the point P. If the tangent to the parabola and the ellipse at that point are perpendicular to each other, then the eccentricity of the ellipse is the question. Okay friends, now for this Given options are 1 by root 2, 1 by 2, 1 by 3, 1 by 5. Okay. See, I have taken one end of the lattice rectum as generally for y square equal to 4ax, it is a comma 2a. But here parabola given as y square equal to 4cx, one end of the lattice rectum can be taken as c comma 2c. One end of the lattice rectum can be taken as c comma 2c. Right. But given that ellipse is passing through this point, ellipse is passing through c comma 2c, then what you will have? C square by a square plus 4c square by b square equal to 1. Right? C square by a square plus 4c square by b square equal to 1. Now taking the c square on the right side, so 1 by a square plus 4 by b square equal to 1 by c square, because ellipse is passing through this point. Okay. Now the tangent at P on the parabola is, so parabola can be taken as t equal to 0. Of course, you can go for slope of the tangent and everything, but I have used the equation t equal to 0. So what is that? y1 equal to 2c of x plus x1. y1 is 2c. So 2c y equal to 2c of x plus c. Cancelling 2c on both sides, y equal to x plus c is the equation of tangent to the parabola at P. And the tangent at P on the ellipse, also find the tangent at P on the ellipse as t equal to 0. That is x1 by a square plus y1 by b square equal to 1. That is cx by a square plus 2cy by b square equal to 1. So taking c on the right side, it is x by a square plus 2y by b square equal to 1 by c. Now this is perpendicular to this tangent y equal to x plus c. These two are perpendicular. Then product of slopes is -1. But what is the product of slopes here? Minus of x coefficient by y coefficient. No? Minus of x coefficient by y coefficient. So minus 1 by a square by 2 by b square. Minus 1 by a square by 2 by b square will be minus b square by 2a square into, what is the slope of this one? Slope of this one is 1. Got my point here? Just a minute. Yeah. So minus b square by a square into 1 equal to -1. Cancelling minus, b square equal to 2a square. When b square equal to 2a square, you can say b is greater than a. In that case, what is the equation for eccentricity? Formula for eccentricity: e square equal to b square minus a square by b square, because here the question is for eccentricity of the ellipse. So when b square equal to a square, 2a square, 2a square minus a square equal to a square by 2a square. A square by 2a square is, even if you want, you can write here. So this is equal to just a minute, 2a square. So will be 1 by 2 only. Okay, friends? Yeah. So e square equal to a square by 2a square, which is 1 by 2. So that e equal to 1 by root 2 is the eccentricity of the ellipse. Now, once again, you see briefly, consider P as c comma 2c. Then this is the condition: 1 by a square plus 4 by b square equal to 1 by c square. Of course, this is not at all used, but given that it is passing, okay, keep it aside. And the tangent at P on the parabola is t equal to 0, which is y1 equal to 2c of x plus x1. This is the tangent. And the tangent at P on the ellipse is again t equal to 0. This is the equation of tangent. Now these two are at perpendicular. Then this is the condition: minus b square by 2a square equal to -1. Then b square equal to 2a square. Hence, you can get the value of E as 1 by root 2. Of course, this condition is not used, but I have taken. No issue. So this is the way you can find the slope of this one, which is 1 by root 2 nano. Now, dear friends, come to the next question. Of course, that is one simple question again. Let us see one more question, fifth one. Let C1 and C2 be two biased coins such that the probabilities of getting head in a single toss are 2 by 3 and 1 by 3 respectively. Getting head is 2 by 3 and getting tail is 1 by 3. Sorry, no. C1 and C2 be two biased coins such that probabilities of getting head in a single throw, getting head on C1 is 2 by 3, getting head on C2 is 1 by 3 respectively. Suppose alpha is the number of heads that appear when C1 tossed twice is independently, and suppose beta is the number of heads that appear when C2 tossed twice independently, then the probability that zeros of the quadratic polynomial, this one, are real and equal is okay. So this is also one interesting question, but not that much difficulty question. See, when this x square minus alpha x plus beta has two real and equal roots, what is the condition then? Delta equal to b square minus 4ac, you know, that is alpha square minus 4 beta equal to 0 implies alpha square equal to beta. So this alpha square equal to beta, where alpha can be either 0 or 1 or 2. Why? Because alpha and beta is the number of heads when C1 and C2 are tossed independently. When C1 tossed independently, alpha is the number of heads for 2 times. No, for 2 times means either you can have no head even for 2 times, you can have 1 head for 2 times, another one it may be tail, otherwise you may have 2 heads getting heads both 2 times. Therefore, here alpha and beta can be in the range of 0, 1, 2. Alpha and beta can be in the range of 0, 1, 2. Okay. Then what will be the range of alpha square? Range of alpha square will be 0, 1, 4. 0, 1, 4. Got the point? But what is the range of 4 beta? 0, 4, 8. So like that, the possible cases of alpha square equal to 4 beta. Possible cases of alpha square equal to 4 beta. When beta alpha is 0, alpha square is 0, then beta must be 0. Otherwise, when beta is 1, alpha square is 4, so that alpha must be 2. When beta equal to 1. So following this condition, in the range of 0, 1, 2, in the range of 0, 1, 2, here alpha, beta must be in the range of 0, 1, 2, no? So alpha square equal to 4 beta, and here itself let me write, and here itself let me write yes. Yes. Okay, friends, now you can have more clarity on this one. And alpha comma beta belongs to 0, 1, 2 implies alpha beta pair can be in 2 ways, 0, 0, 2, 1. Alpha beta pair can be in two ways, either 0 0 or 2 1. So in case of alpha beta 0 0, alpha beta 0 0 means no head on C1, no head on C2, because alpha is the number of heads on C1, beta is the number of heads on C2. When alpha is 0 means no head on C1, beta is 0, no head on C2, no head on C2. Therefore, no head on C1 according to number of heads in two throws can be taken as 2CR into P power 2 minus R and Q power R, where P and Q are success and failure probabilities. So getting head on C1 is 2 by 3, getting tail on C1 is 1 by 3, because sum must be 1, no? That's why. So no head means 2C0, 2 by 3 power 0, because no head, and 1 by 3 power 2. At that time, beta is also 0. So for beta 0, number of heads is 0. So that 2C0, why it is 2C0? 2 times. That means from the, random variables, from the concept of random variables, right? When a coin is tossed for n times, so number of success or success can be taken as NCR P power R Q power n minus R. So from that formula, you can write the probability of alpha 0 and beta 0 as 2C0, 2 by 3 power 0 into 1 by 3 square, and for beta 0, 2C0, 1 by 3 power 0 and 2 by 3 square. So on simplification, just you will have what you say, it is 1 by 9. Sorry, this is a 2C01, this is 1, 1 by 3 square, 1 by 9, and here this is 1, this is 1, and 2 square, this is 1 by 9, sorry, 4 by 9. On the whole, it is 2 by 9 square. Otherwise, very clearly what you can write, it is 1 by 9 into 4 by 9. Okay, yeah, you can say like this. It is equal to 1 by 9 of 4 by 9. Okay, yeah, this is equal to 4 by 81. Okay friends, this is 1 1 1 by 9, 1 1 4 by 9 equal to, yeah, it is 4 by 81, dear friends. Then in another case, alpha beta 2 comma 1, we have two options, 0 0 1 case, 2 1 1 case. So alpha beta 2 comma 1 can be taken as alpha 2 for 2 times, it is 2C2, 2 by 3 power 2 into 1 by 3 power 0. This is 1, beta equal to 1, so that it is 2C1, but here success is 1 by 3, no, 1 by 3 power 1, 2 by 3 power 1. So it is now 2C2 is 1 into 2 by 3. Okay, this is 1, 2 by 3 means 4 by 9, 1 into this is 4 by 9 into this one, and here 2C1 is 2 none, 2C1 is 2 into this is what, 2 by 9. Let me write here, yeah, this is 2C1 1 into 4 by 9, yeah, 4 by 9 of here 2 into 2 by 9 again, 2 divided by 9. So on the whole, it is 16 by 81 you will have. So this is 1, 4 by 9 and 1. So that 4 by 9. This is 2, 1 by 3 into 2 by 3, 2 by 9. 4 to the 8 to the 16 by 81 is the probability. Got my point here. So like this, because these two are possible cases, you can go for P of E equal to sum of these two. These are two different cases, two independent cases. Therefore, that's mutually exclusive cases. Either this may be happened to get alpha square equal to 4 beta, or this can be happened. Therefore, P of A can be taken as sum of these two, which is 4 by 81 plus 16 by 81, 20 by 81 is the right answer, my dear friends. I think you got it. Now, let us go for next question. See this one. Question number 6. It is, consider all rectangles lying in the region. Consider all rectangles lying in the region. This is the region defined. Set of x comma y belongs to R by R. R cross R means it is the Cartesian product of R and R, means in the whole xy plane. Set of x comma y in the whole xy plane. R cross R means, so x for R, y for R. Okay, that means x belongs to R and y belongs to R. X can be any real value, y can be any real value. Therefore, it is a point in the plane where 0 less than or equal to x less than or equal to pi by 2. Now, condition is given for this. 0 less than or equal to y less than or equal to 2 sine 2x. This is the condition for y, right? Having one side on the x-axis, the area of the rectangle which has the maximum perimeter among all such rectangles. This is given that consider all rectangles lying in the region. This is the region of x comma y, lying in the region, such that one side on the x-axis, that means rectangles should be with the one side on this x-axis. Now let us see how this will be defined. Now these are the given options. Okay. So from this one, x will be taken from 0 to pi by 2, whereas y is the curve, y below 2 sine 2x, below 2 sine 2x, where x is in the interval 0 to pi by 2. When x is 0 to pi by 2, 2x will be 0 to pi. When x is 0 to pi by 2, 2x will be 0 to pi. According to 0 to pi, sin x graph, this green curve is y equal to 2 sine 2x. Y equal to 2 sine 2x. Right. But here rectangles have been inscribed in this. This is the whole region. In the whole region below the curve and above the x-axis, 0 less than x less than or equal to pi by 2 means from x 0 to pi by 2. But y is below this curve means above x-axis. Above x-axis means 0, y is greater than or equal to 0, less than or equal to sine 2x. So within the region, rectangles have been inscribed such that x-axis on the one side of the rectangle is on x-axis. Right. Now, let us construct and consider one side of this rectangle is 2a, centered at pi by 4. On the right side of pi by 4 it is a, on the left side of pi by 4 it is a. Let the width is b. Now, this point will be pi by 4 plus a at b. Otherwise, this point can be taken as pi by 4 minus a b. Either pi by 4 plus a b and pi by 4 minus a b will be on the curve y equal to sine 2x. So from the adjacent figure, p pi by 4 plus a comma b, this is the point pi by 4 plus a, x coordinate, b is the y coordinate, lies on the curve. If that is the case, just you can substitute and get the condition b equal to 2 cos 2a. Get the condition b equal to 2 cos 2a, right? Where a is in the interval 0 to pi by 4 only. Why? Because from this one, taking a pi by 4 to pi by 2, then what is the range of a here? A is from pi by 4 to pi by, here, when a is at this one, at the minimum, a will be 0. At the maximum, this length only. This length means pi by 4 only. That's why side of a can be, that means value of a can be taken in the interval 0 to pi by 4. Now, what is the perimeter? Perimeter is double of 2a plus b, no? Double of 2a plus b. That should be minimum. Perimeter P is 2 of 2a plus b. So 2 of 2a plus 2 cos 2a can be taken like this. Let us consider this as f of a. Then f dash a equal to 4 of 1 minus 2 sin 2a. When it is equal to 0, sin 2a equal to 1 by 2. So where 2a range is 0 to pi by 2. So that will be pi by 2 when 2a equal to pi by 6. When 2a equal to pi by 6, a equal to pi by 12. When a equal to pi by 12, b is this one. When a equal to pi by 12, b is this one. Right. Now, what is the area? 2a into b. So area 2a into b can be taken as pi by 2 root 2. So that is the. So this is the construction according to the data given. This is the curve y equal to 2 sin 2x, where x is from 0 to pi by 2. Then 2x will be taken from 0 to pi. This is the graph of sin 2x. Now one rectangle inscribed in the curve. Now centering at pi by 4, consider a units on the right side, a units on the left side. So that one side is of 2a length, one side is of b length. Right. Now this point can be taken as pi by 4 plus a comma b, whereas this point can be taken as pi by 4 minus a comma b. Any point can be taken on the curve to get the relation between a and b. So substituting that, this is the condition. Because knowing the relation between a and b, you can go for the function of perimeter and you can optimize that. You can optimize that because given that perimeter is least, so that f dash a can be taken 0. According to that, a can be found, then area can be found in this manner. Okay, then. So this is also one good question. Now let us go for section 2. Let us go for the section 2 in the next video. So dear friends, I strongly believe that you have understood all this discussion very clearly, and you have been satisfied with this session from GRM Toppers classes. And dear friends, please share this video and help the students as much as possible. So till then, I will come with another part of this paper 1 dealing with section 2 as soon as possible. Till then, have a nice time. Thank you.